Similar triangles, exercise 8.1. Fourth question and fifth question are looking like similar, but there is a difference between these two questions. That's why I have written like this. So now prove that a line drawn through the midpoint, of one side of a triangle. So there is a triangle. For triangle, there is a one side of a midpoint. On triangle, one side we have to take a midpoint. So suppose the side, let's name the sides A, B, C. So there is a midpoint. D is a midpoint on the one side of a triangle. One side of a triangle parallel to the other side. One side of a triangle parallel to the other side bisects the third side. We have to show that bisects the third side and parallel. So solution will start. Let triangle ABC, in triangle ABC, D is a midpoint on AB. So D is a midpoint means this line segment is divided into two equal halves. Midpoint will divide the line segment into two equal halves. So we can write this as AD is equals to DB. So this midpoint is parallel to the other side. This midpoint is parallel to the other side. Let's name this as E. So if DE is parallel to BC, we required to prove for this question is we have to show AE is equals to EC. That will bisect the third side. D line is bisecting the third side. So if DE is parallel to BC, by basic proportionality theorem, required to prove AE equal to EC. Then so if ADE is parallel to BC, we can write by basic proportionality theorem corresponding sides in a ratio. So AD by DB is equals to AE by EC. Now from 1, value of DB is nothing but AD. So AD by, instead of writing DB, we are writing AD is equals to AE by EC. 1 and 1 will get cancelled. AD and AD will get cancelled. The answer will be 1. So 1 equal to AE by EC. Cross multiplication. By doing cross multiplication, we'll get EC is equals to AE. That means we are showing again E is also a midpoint. That means here whatever the length EC is there, that is equals to AE. So we show that E is also a midpoint to the other side of a triangle. So E is a midpoint of third side of a triangle. So then therefore we can say DE is also parallel to BC. Hence proved. Now in this question, prove that a line joining the midpoints, one line is joining the midpoints of any two sides of a triangle. So now triangle, two midpoints are there. So one side, first side and second side are the midpoints of a triangle. Name this as A, B, C. So D and E are the midpoints of a triangle. The difference between here, they said only one side of a triangle. Here two sides of a triangle, difference between these two sums. So now solution will start proof. So now if it is a midpoint in triangle ABC, D and E are the midpoints on midpoints of AB and AC respectively. So now AD midpoint means midpoint will divide the line segment into two equal halves. So whatever the measurement of AD is there, that is equal to DB. So we can write as AD is equals to DB. From this, transpose DB to LHS, we'll get AD by DB. Here if we transpose DB to LHS, here nothing will be, so we will consider this as 1. So nothing is there means it will be 1. Keep this an equation 1. Now same thing, if E is a midpoint, AC line segment will be divided into two equal halves. So AE is equals to EC. Then if E is a midpoint, we can write AE is equals to EC. Again transpose EC to the RHS. So AE equal to AE by EC is equals to 1. Keep this in equation 2. So from equation 1 and 2, we can equate the LHS. From 1 and 2, equating the LHS, here 1 is common, so we are not going to write this one. We are equating the LHS. So answer will be AD by DB is equals to AE by EC. So now that means if the corresponding sides are in a ratio, we are showing that by this is like basic proportionality theorem. If the corresponding sides AD by DB is equals to AE by EC, by converse of basic proportionality theorem, if the corresponding sides are in the ratio, then we can write DE is parallel to BC by converse of BPT, means basic proportionality theorem. Thanks for watching. Please subscribe my channel and share this video to your friends.